We're going to be starting Chapter 2, Lesson 7, Interpret the Remainder, where we're going to apply and extend previous understandings of multiplication and division to multiply and divide fractions. So unlike the other lessons where we were figuring out how to divide in different strategies, whether it be drawing it out, partial products, or the more standard algorithm, now we're going to be solving a lot of word problems and figuring out, all right, we always have this R, this remainder. What does that remainder actually mean? So in order to understand what it actually means, you need to understand the parts and the wholes that are being played into an equation. And so even though number one doesn't start with a part whole picture box, we're going to create the picture box for number one and figure out how and why they have a fraction. When we interpret the remainder, there are three options we have. So before I even start too much on that, I'm just going to take a scratch paper and discuss a little something. Let's pretend that the answer was 3 remainder 7. This lesson, Interpret the Remainder, will have you take your remainder 7, and figure out what does that mean. Does that mean the answer is going to round down to 3, where you don't use the remainder? Will that mean you need to round up to the whole number 4? So instead of 3, it'll be 4. Or will you create a fraction where you have 3 and 7 over your denominator, and your denominator will be whatever your divisor was in the word problem. Which right now, since you don't have a word problem, you don't have a divisor. You don't have a denominator. So there are always going to be three options. We're going to look at the whole number, and we're either going to keep it the same, we'll round up by one whole, or we'll be putting it as a fraction. So you can see here for number one, they took theirs and they turned it into a fraction. And you're going to be like, where did they get the 3 and the 4? Nowhere here does it say 3 or 4, and I'm going to show you, and I'm going to break that down for you. So even though they did number one for us, I'm going to explain number one, and then from there we'll work on number two. Warren, which in this case is a name, Warren spent 140 hours making 16 wooden toy trucks for a craft fair. If he spent the same amount of time making each truck, how many hours did he spend making each truck? So I'm going to read that again thinking, do we have a total of something? Is there a total going on here, yes or no? If so, it'll go on top, and if not, you'll put x equals, and that's what we're trying to find out. So in this equation, what is going on, and is there a total of something? So right now I know that there's a boy named Warren. Warren spent 140 hours making 16 wooden toy trucks for a craft fair. If he spent the same amount of time making each truck, how many hours did he spend making each truck? So reading through it again, I'm starting to see there's a boy named Warren, and he's making wooden toy trucks, and for a craft fair, and he spent this, so many hours doing it, and we want to find out how much did it take to make one truck? How many hours did it take to make one truck? So we don't know the amount of hours he spent making one truck, but we know the total amount of hours he spent, which goes on top, is 140 total hours working, making 16 trucks. And these are wooden toy trucks, okay? And if you want to add even more detail, that's fine. But on the top goes the total, and in this case, this boy Warren spent a total of 140 hours making 16 toy trucks. Now we're going to do the part wholes, and we're going to figure out what does one box represent. So I'm going to read that again and figure out what does one box represent. So what's the one item that we're creating, or the one item we're putting everything into? Warren spent 140 hours total making 16 wooden toy trucks for a craft fair. If he spent the same amount of time making one truck, how many hours did he spend making each truck? So here I could see, just because of the hint, that there is an each truck. So each box represents each truck. So one box represents truck 1. The next box represents truck 2. Do we know the amount of trucks there are total? Let's read it again and see if there's a total amount of trucks. If not, we're going to figure out, we'll put truck question mark and then figure out how many trucks there are. So let's read to figure out how many trucks we have, or that's what we're looking for. Warren spent 140 hours making 16 wooden toy trucks. So now we know there are 16 total wooden trucks because it says 16 toy trucks. Now what goes inside each truck? Inside this truck, we want to figure out how many hours it took him to make one truck, how many hours it took him to make the second truck, how many hours it took him to make the 16th truck. So the amount of hours goes inside of here to make one truck. Let's read this again to figure out how many hours he spent making one truck. Warren spent 140 hours making 16 wooden toy trucks for a craft fair. If he spent the same amount of time making each truck, how many trucks did he spend? How many hours did he spend making each truck? So what they're saying, what they're saying here is they don't know how much time it took him to make truck number 1. That's an X. We don't know. But it does say he spent the same amount of time making each truck. So even though we don't know how long it took him to make truck 2, it's the same amount, same letter. We don't know how long it took him to make truck 16, but it's the same letter, same amount. So the X is the total hours spent making one truck. So, if there's a total of 140 hours, and that's making 16 trucks, and we want to find the amount of hours it spent to take him make one truck, will the answer be bigger than or less than 140? You're right, it should be less than. Because in 140 hours, he can make 16 trucks. So in one truck, it should be less than that. So we're going to look at our 4 options. Addition, subtraction, multiplication, division. And we're going to circle the 2 operations that get smaller. When you add numbers together, it often makes it bigger. Subtraction makes it smaller. Multiplication makes it bigger. And division makes it smaller. So looking at this, we're either going to subtract or divide, and you could do either one. One way you could attack this problem is do 140 minus 16 and minus 16 and you're going to keep minusing 16 until you get to 0. And then you're going to count how many times you subtracted 16. So far we have 2. And you're going to keep going all the way until you hit 0. And you can see that's going to take a really long time. Because repeated subtraction is division, the other way we could solve this problem is do 140 divided by 16. Because division is repeated subtraction, and you can see that we're repeating the same letter X 16 times. So you do 140 divided by 16. This is where you're going to use your cheat sheet. Unfortunately, our cheat sheet does not go up to our 16s. But we can use our minds and start doing 16 times 0 equals 0. 16 times 1 equals 16. 16 times 2 equals 32. And now we're going to ask ourselves, buddy, 16 times what number gets closer or equal to 1 without going over? And you can see here with the 3 answers we have so far, 32 and 16 are too high, so we have to use 16 times 0. 16 times 0 is 0. Subtract, bring down the 4. Keep in mind you want to make sure that 1 is less than 16 before bringing the next number down. Now we have the number 14. We're looking at our answers 0, 16, and 32. And we want to get close to or equal to 14 without going over. 32 is too big, it goes over. 16 is bigger than 14, so it goes over. So again, we're going to have to use 0. 16 times 0 is 0. Subtract equals 14. And we want to make sure that our number so far is less than our divisor, and it is. So now we're going to bring down the 0. Now we're going to ask ourselves 16 times what number gets close to or equal to 140 without going over. You can see the 32 is too small. So at this point, If I try doing 16 times 3 or 4, I don't think it'll get us close enough to 140. So I'm going to try 16 times 5. I'm going to skip a couple of numbers, only because 32 is very far from 140. If you're not familiar with your 5s, you can use your cheat sheet. And remember, we're going to start at the bottom right number and multiply by the ones on top. So we're going to multiply 5 times 6. 5 times 6 equals 30. We're going to regroup the 3. Now we're going to multiply 5 by the rest of the numbers on top, going from right to left. So 5 times 1, which is 5 plus 3, 5, 6, 7, 8. You can see 80 is less than 140, so we're going to try again. 16 times 6. And you can use your 6's here. We're going to start at the bottom right. 6 times 6. 6 times 6 equals 36. We're going to regroup the 3 on top of the next number. We're going to multiply by. Then we're going to multiply the bottom right by the top. 6 times 1. 6 times 1 is 6 plus 3. 6. The number after 6 is 7, 8, 9. You can see here that 96 is still less than 140, so we're going to try the next number. 16 times 7. And now, since our divisor is 7, we'll use the 7's cheat sheet. We're multiplying everything on top by the number 7. So we're going to start with 7 times 6, because it's the right number. 7 times 6 is 42. We're going to regroup the 4 on top of the next number we're going to multiply by. Then we're going to do 7 times 1. 7 times 1 is 7, plus 4 is, the number after 7 is 8, 9, 10, 11. Ooh, 112 is getting closer to 140 than the other two. Let's try 16 times 8. Over here I'm going to have to use the next sheet. Our divisor is 8, and we're going to multiply by the ones on top. 8 times 6. 8 times 6 equals 48, and regroup the 4. Then we're going to do 8 times 1 equals 8. Oops. Plus our 4. The number after 8 is 9. So we're going to do 9, 10, 11, 12. Ooh, 128 is getting even closer, but let's try 9 just in case. 16 times 9. I'm going to start with 9 times 6. 9 times 6 equals 54. Regroup the 5. Then we're going to do 9 times 1, which is 9, plus 5. The number after 9 is 10. 10, 11, 12, 13, 14. You can see here 144 is just a little too much, so we're going to have to use the math back. 16 times 8. So, buddy, 16 times what number gets close or equal to 140 without going over? It's 16 times 8. And 16 times 8 equals 128, so that is what we will subtract. 0 minus 8, we will regroup. 10 minus 8 is now 2. 3 minus 2 is now 1. So now we have 8, remainder 12. Now, as I said in the beginning of the lesson, we're going to figure out what to do with that remainder. So before we can figure out what to do with the remainder, we're going to have to figure out what all these numbers mean. So what does the 8 represent? And what does the remainder 12 represent? So let's read it. Warren spent 140 total hours making 16 wooden toy trucks for a craft fair. If he spent the same amount of time making each truck, how many hours did he spend making each truck? Since it's asking for how many hours he spent making this truck, the 8 is the amount of hours he spent. So he spent 8 hours making one truck. But what does the remainder 12 mean? In this particular scenario, because it's talking about hours, they're saying that the next, he made, how can I describe that one? It took him 8 hours and a little bit extra time to make 16 trucks. It didn't quite take him 9 hours, but it did take him more than 8 hours. So that remainder 12 means it's part of, it's almost like your minutes. So like let's think about like a TV show and it takes 1 hour to watch like a regular drama or whatnot, sometimes if you want to watch a shorter sitcom, it might only take 30 minutes, so it's not a full hour. That's what this remainder means. It means that it took him 8 full hours and then some extra time that was more than 8 hours, but less than 9 hours. So this is, remainder 12 is like part of that hour. So here, you know, this whole chapter, we're always going to have 3 different answers, 3 different possible answers. So the 8 remainder 12, the answer could either be, we keep it at the whole number 8. And we're just going to round down, so to speak. And then the remainder 12 we're going to ignore. Or the second answer is, it's going to round up to 9, to the next whole number. 8 plus 1 is 9. Or the last one is, it's going to be some form of a fraction. 8 with a fraction. And the remainder 12 will be our numerator. And then we'll have to figure out our denominator. And our denominator is whatever our divisor is. So right here, this will be the denominator. Because, oops, denominator. And that would be our, because that's our divisor. So this would be our numerator. The numerator is the top number of a fraction, and the divisor will be our denominator. So it's going to be one of these answers. Let's read through the equation again and think, is the answer 8? If they're asking for how many hours it took him to make one truck, it took him more than 8 hours. That remainder 12 means it took him more than that. So 8 hours is too little. He spent more than 8 hours making each truck. So it's not going to be 8. Did it take him 9 hours to make each truck? No, it took him less than 9 hours to make each truck. So we're not going to use the number 9. Now here, we're going to use a fraction because it took him a fraction of a full hour to make each truck. And the way that we did it was we took the remainder 12, that became our numerator, and our denominator came from our divisor, which is 16. And then you're going to be like, Ms. Tolentino, they have a different answer than you. That's because they simplified. So after they got their answer of 8 and 12 over 16, then the next thing that they did was that they simplified. So they thought to themselves, what two numbers, or what, not two numbers, what number can you divide by top and bottom that can go into both 12 and 16? In other words, what are the common factors? And if you look at it, you could say they're both even numbers, so you could divide by 2 on top and bottom. 12 divided by 2 is 6, and 16 divided by 2 is 8. You could say, hey, they're both still even. You could divide by 2 again. 6 divided by 2 is 3, and 8 divided by 2 is 4. And so that's how they got the fraction part of it. That's how they showed their work for the fraction. They got 3/4. 12 over 16 is the same as 6/8, and it's also the same as 3/4. And so they got 8 and 3/4 just by simplifying. And keep in mind, 8 was the amount of hours that they worked. So your final answer is 8 and 3/4 hours. Because there's a lot of interpreting the remainder, you won't be required to actually have to check your answer through multiplication, but I would highly recommend it, just because it'll always make sure that you're at least always on the right track and you at least have this right answer. But the most important thing that they're looking for is, what are you doing with that remainder? So one thing you for sure need to do is always write out 8 remainder 12 and then draw an arrow for the 3 answers it can be. Your answer could be 8, 9, or 8 and a fraction. And for this case, it's the fraction that works. Sometimes it will be where you have to round down. That's your answer. Sometimes it'll be where you have to round up. It kind of depends on what the remainder means. The second thing you need to do that you didn't have to do in previous lessons is when you get to your quotient, you need to describe and label what it means. 8 is the hours, and 12 is part of an hour. Now, if you want, you could put it both over here and when you rewrite it down here. So 8 is the hours worked, and the remainder 12 is part of an hour. Now I'll show you doing one more problem. Another example where it's not going to be a fraction this time. So stay tuned in just a second, and let me just get another piece of paper. Okay, here's the second problem. And we're going to make sure to kind of show a lot of the work that we showed previously, which is the part whole picture boxes. But more importantly, this lesson that we didn't have to do before is looking over here for the 3 options your answer is going to be, crossing out 2 of the ones that don't make sense and circling the one that does, and making sure to label what the quotient means. What does the whole number represent, and what does the remainder represent? And then make sure to put your final answer down. So, Marcia is a name, has 412 bouquets of flowers for centerpieces. She uses 8 flowers for each centerpiece. How many centerpieces can she make? So reading through this, you do need to know a couple of words here. For example, bouquets of flowers is like bundles or like groups of flowers. And centerpieces are kind of like decorations. So if you've ever been to a wedding or a cotillion or some other fancy event, there's usually like a table, and at that table there's usually flowers put inside of a nice vase. That vase is called a centerpiece because it's in the center of the table, and it usually is there for decoration. So now that we know some of these vocab words, let's read it again and figure out, do we have a total of something? If so, it goes on top. And what are we doing with that total? So Marcia has 412 bouquets of flowers for centerpieces. She uses 8 flowers for each centerpiece. How many centerpieces can she make? So reading through this again, we have a total amount of flowers. And so I'm going to put that on top. There are 412 total flowers for centerpieces. And centerpieces are for decorations that'll go in the middle of the table. Now I'm going to read it again and figure out, what are we doing with these 412 flowers? Marcia has 412 bouquets of flowers for centerpieces. She uses 8 flowers for each centerpiece. How many centerpieces can she make? So here we have, like in the description of, she uses 8 flowers for each centerpiece. So each centerpiece means this is each box. So whenever you see that each centerpiece, then it's kind of like saying each box. So each box represents one of something, one centerpiece. So this is centerpiece 1. This is centerpiece 2. I want to read it again and figure out how many centerpieces we have. If we don't know, that becomes a question mark. If we do know, then that's how many centerpieces we have. That's how many boxes we have. Marcia has 412 bouquets of flowers for centerpieces. She uses 8 flowers for each centerpiece. How many centerpieces can she make? How many centerpieces can she make means that's what we're figuring out. So this is our question mark right here. This is going to be how many centerpieces she can make. Now let's read it again and figure out how many flowers goes in one centerpiece. Marcia has 412 bouquets of flowers for centerpieces. She uses 8 flowers for each centerpiece. So in centerpiece 1, there's 8 flowers. In centerpiece 2, there's 8 flowers. In this centerpiece, there'll be 8 flowers, and I just don't know how many centerpieces that will be. So now we're going to read it again and figure out whether we're going to add, subtract, multiply, or divide these numbers. Well, here we have 412 total centerpieces, and we're going to take 8 away, put it into one vase for a centerpiece. We're going to take 8 more of those away, put in another centerpiece. Take 8 away and put another centerpiece. So already just hearing what's going on, we have a total of 412 flowers, and we're getting smaller. We're taking some away. So addition generally gets bigger, subtraction gets smaller, multiplication gets bigger, division gets smaller. So we could either subtract or divide. Like I said before, you could do 412 minus 8, minus 8. minus 8, minus 8, all the way until you run out of flowers, so until you have 0 flowers left. Or, since you're always subtracting the same number, division is repeated subtraction. So you could do 412 divided by 8. And even though I don't mind dividing with double-digit divisors, what makes this one a little bit easier than the other one is that we already have our 8s written out. So our 8s for the divisor we could use the cheat sheet for. And so from here, 412 divided by 8, I'll say, buddy, 8 times what number gets close to or equal to 4 without going over. So we want the answer, which are the reds, to be close to or equal to 4 without going over. This second column is already way past 4, so we're going to look somewhere here. 16 is larger than 4. 8 is larger than 4, so we're going to have to use the number 0. The math fact, 8 times 0 equals 0. So, buddy, 8 times 0 equals 0, and that gets closest to 4 without going over. 4 minus 0 is 4, and we're going to bring down the 1. And we're going to ask ourselves, buddy, 8 times what number gets closer or equal to 41 without going over? You can see here that these ones are a little too large, and so we're going to look at this column. 8 times 5 is 40, and that's really close. And 8 times 6 is 48, and that's a little too much. So we're going to use the math fact. Buddy, 8 times what number gets closer or equal to 41? 8 times 5 is 40. When we subtract, we have 1 left over, and 1 is less than our divisor. So we can bring down the 2. We're going to ask ourselves, 8 times what number gets closer or equal to 12 without going over? You can see this column's a little too large, so we're going to stick here and say 8 times 0 is 0. That's not too close to 12. 8 is getting closer to 12, and 16 goes over. So since 16 is too much, we'll use the math fact. 8 times 1 equals 8. 8 times 1 equals 8. And when we subtract, we get 4. So now we have a remainder of 4. So at this point, there's going to be 3 possible answers. We're going to have 51, remainder 4, can either mean we stick with the number 51, and we're going to drop the remainder 4. So we could round down to 51. The second possible answer is that remainder 4 is going to bump up the whole number by 1. We're going to round up. So instead of it being 51, 51 plus 1 is 52. And our third possibility is going to be a fraction, where we do 51, and remember the remainder will become the numerator. So it'll be 51 and 4 over, because the remainder becomes the numerator, the divisor, and this would be your denominator. Our divisor would become our denominator. So we have 3 different options here, 51, 52, and 51 and 4/8. But only one of them would make sense into the story. So what we have to do is figure out, what does the 51 represent in this story? So let's see. She has a total of 412 flowers, 4 centerpieces, and each centerpiece has 8 flowers. Each 8 flowers for 1 centerpiece. So how many centerpieces can she make? These are the amount of centerpieces she can make. She can make 51 centerpieces. So she can make 51 centerpieces. Now here's the tricky part. What does the 4 represent? So let's think about what happened in the story. What happened in the story was there's 412 flowers. She took 8 away, created a centerpiece. Took 8 away, created a centerpiece. Took 8 away, created a centerpiece. So she was able to make 51 centerpieces. That went all the way up to 51. Then what happened? She did minus 8, minus 8, minus 8, minus 8, 412, minus 8, 4, next one, minus 8, minus 8. And then she had 4 left over. What did she have left over? She had 4 flowers left over. So this 4 is 4 extra flowers. Does that make sense? Because there's a 412 total flowers, and she took away 8, created 1 centerpiece. Took away 8, created another centerpiece. Kept doing it until she made 51 centerpieces. And then she had 4 left over. So she had 4 flowers for another centerpiece. So can she make 52 centerpieces? No, because she only has 4 flowers and she needs 8 flowers to make a centerpiece. So she cannot make 52 centerpieces because she only has 4 flowers and she needs 8 flowers to do that. Can she make half of a centerpiece? Can she do every single table gets 51 tables get 8 flowers and then the other one only gets 4 flowers? Well, think about it. We're at a wedding right now, and every single table has a vase in it, and they get 1, 2, 3, 4, 5, 6, 7, 8 flowers. Okay, think about all these flowers here. And that's 51 tables get that. And then you go to this one table, and there's only 1, 2, 3, 4 flowers. Would that look nice if every single table has a filled centerpiece with 8 flowers and one table doesn't? No, so you don't want that one table. Like, think about if you went to a cotillion or something. Every single table has 8 flowers and your table has 4. That would be mean to the guest. So what are you going to do? You're going to round down. You can create 51 full centerpieces with 8 flowers each, and then you have 4 extra flowers, which is good because what if, one flower is not as pretty? You have 4 extra flowers. But you don't want to create a centerpiece that's only half full. And you can't create a new one because you don't have enough. So your answer is 51. She can make 51 centerpieces. So your final answer is 51 centerpieces. Keep in mind, I would love if you could double check your answer, 51 times 8 plus 4, and make sure you got the 412. Even if you just do it on a calculator, because at this point, we're not focused so much on getting the right answer, but figuring out what to do with the remainder. So if I were you, I would just type in a calculator, 8 times 51 plus 4, make sure you get 412. But the most important step is you do this. 51 remainder 4, you have 3 possible answers, cross out the ones that don't make sense, and circle the one that does. Making sure to label what the quotient means. What's the whole number represent? What does the remainder represent? And sometimes they're the same, and sometimes they're different. Like here, one's talking about centerpieces, and this one's talking about flowers. Whereas last time, it was talking about hours and part of an hour. So they kind of relates. So I hope that this video helps. I know that there are quite a few problems left to do, 3, 4, 5, and 6, but I don't want to do them all for you. I want you to start thinking, this lesson itself, I only did 2 problems and it took me more than half an hour. So yes, this work is going to take you maybe a couple of hours to do, maybe 2 hours to do both the front and the back. And, there's less problems than in usual lessons where there's probably double this, but it's word problems. They're word problems and it's going to take longer. And don't get frustrated, but think about it. If you have a total go on top, what does each box represent? What goes inside each box? And really take your time to struggle, to think, to stretch your brain a little, rather than just give up and say, I don't know what to do. I don't know how to do this. At the very least, if you don't know which of the 3 answers it is, solve the answer. Get to 8 remainder 12. At least write out 8, 9, and then your fraction, and then I can help you cross it out later. But whatever you do, don't just sit there and not try. I hope that this helped, and I look forward to seeing how you did tomorrow.